We have our hammer. This is a liquid nitrogen dewar, also known as a liquid nitrogen vacuum flask. A vacuum flask, as the name implies, has a vacuum, but you may be wondering where this vacuum is. The whole thing isn't under a vacuum. It's actually two cylinders. One cylinder, which is the center cylinder, which holds the liquid nitrogen, then an evacuated space, and then the outer tank, which you can see here. Then there is a neck that connects them, made of plastic or something that doesn't conduct as much heat, so the liquid nitrogen stays for a long time. Opening up, we see a cap. We can take that cap off, and we see that it's quite cold. Now, you'd be wondering, it's not like a screw cap, it just slides right out. This is because if the liquid nitrogen pressurizes, it could explode. You can see the green down there, which is the insulation that connects the outer lip to the inner tank. This was originally meant for cow semen, so there's these dipping rods in there. This one has holes on the bottom, but the other one doesn't. Let's take that one out. And you can see the liquid nitrogen in there. It's quite cold, only about negative 320 degrees Fahrenheit. Let's put it back in there before we lose it all. This is a great storage vessel, but for experiments, let's transfer it into something smaller. A thermos. Same idea as the vacuum flask. Internal container, external container, vacuum, insulation in between. A vacuum doesn't conduct as much heat as regular insulation would, making it ideal for this scenario. Now let's take it over to the bench and do some experiments. Let's first go over the safety behind liquid nitrogen before we try any experiments. Liquid nitrogen is extremely cold. You get frostbite in a couple seconds of touching it. It's about negative 320 degrees Fahrenheit. That's scary considering what we're mostly made up of, water, freezes at 32 degrees. So that's far, far colder than what it would take to freeze our hands. And touching it will freeze your hands almost instantly, giving you frostbite, which is very similar to very hot burns, like touching in a 400-degree oven. We have some comforts with liquid nitrogen due to the heat difference. You can see when I drop it, it forms little drops that skate around. This is because there's a layer of gas underneath which keeps it from fully contenting what's below until it brings it down to the temperature where it can contact. This gives us a couple seconds to get our hands out of the way before it'll start to freeze us. If it stays on there for too long, it'll begin to freeze the water and cause skin damage. Currently, we have liquid form of what makes up 70-ish% of our atmosphere, nitrogen. But let's condense another 20% of something that's actually more important to us, oxygen. Here I have a tank of oxygen, which I'll just be using the regulator, flowing it through the tube with a pipette at the end, where hopefully the oxygen will condense at the bottom. Just throw the tube down. Make sure the tank's open. And we let the air flow. The nitrogen will actually boil off, which will allow it to cool down. Now that some time has passed, let's turn off the oxygen and take a look at what we got. You can actually see the fact that it's blue in color. It also has the interesting effect of being magnetic. Now you can't see it. You can see when I touch it, it boils quite rapidly. Now the reason why this is happening and it's condensing down is because the boiling point of liquid oxygen is actually higher than the boiling point of liquid nitrogen, which means liquid nitrogen is colder in comparison. Now that we have it built back up, let's grab the pipette out of the tube. If we cover up the pipette and let the pressure build, it'll come shooting out. Another thing that can happen is if we tip it, all the oxygen comes shooting out. And the pipette warms up quite quickly. Let's pour off some more liquid nitrogen into this 50 milliliter beaker. This time, I have a glove. Let's submerge one of the fingers. Can you tell what's happening? The balloon, in the case glove, is shrinking. No air is escaping out the top here. This has been tied off. What's happening is liquid nitrogen is condensing the gas into a liquid, causing the volume to shrink. What do you think is going to happen when I take it out of the liquid nitrogen and let it warm back up? Balloon, as it heats up, is starting to expand as liquid gases go back into the gaseous form. We can speed this process up by moving it around a little bit and moving it out of the cold region. And there we have it, a glove, back to its original size. While I was cleaning up for this video, I noticed I still had a box of these sitting on my bench. Sparklers. Basically a tamer version of thermite. I wondered what would happen if I lit one of these and stuck it in the liquid nitrogen. So let's find out. First we're going to need to pour some liquid nitrogen into here and then light it. Here's the spark roller, and let's go in. I was quite impressed at how well it stayed lit while being submerged. It also seemed to turn the liquid nitrogen a bit of a yellow color. Now, this makes sense due to the fact that the oxidizer and the fuel are all mixed in. It didn't need oxygen to burn. Liquid nitrogen is purely nitrogen, but you saw as it got out, it had a little bit of trouble burning, and then once it got closer to the top where there was more oxygen, it was able to burn as a normal sparkler would. I'm interested to see what the impurity looks like after all the nitrogen evaporates. Now that we're down to it, it went from a green to a blue once all the nitrogen evaporated. This is probably one of the products of combustion in the sparkler. I'll have to do a bit more research and figure out what that is. On my Discord server, I asked my people. On the Discord server I host, I asked the people what they wanted to see in this video. One of them responded with, they wanted to see a flamethrower versus liquid nitrogen. Unfortunately, my flamethrower is in the shop, so the best I can do is a blowtorch. Let's light it and see what happens with the nitrogen. Well, taking it with that, you see the nitrogen won. But that's due to the fact that once the nitrogen coated everything, it took away all the oxygen and displaced it. And for combustion to occur, you need an oxygen source. These two vents down here, as the high pressure stream of propane comes to the top, these pull in oxygen, which then will ignite at the tip. If there's no oxygen, there's no ignition. Another person on my Discord server did something quite cool. Before I got my hands on the liquid nitrogen, he actually solidified mercury. So let's do that. And there we have it, our solid mercury. Let's give it some time to warm up. Now let's do what everyone else does and shatter some foods. Got our 50 milliliter beaker again. Let's throw some liquid nitrogen in it. Now let's drop one of the tomatoes in. Now it's really, really cold. Let's take it out. We have our hammer. And it shatters. Like it's made out of glass. Thanks for watching and see you next time. If you need to place a talk science or just hang out, check out my Discord server. There are many like-minded individuals there, and we'd love to hear from you. If you want to see the continuation of this series, consider subscribing. Each episode will get better and better as I get more experienced. Have any questions or anything to say? Drop in the comments section below. I love hearing from viewers. It's my favorite part.
Well, I don't know, but I've been told uranium ore's worth more than gold. Sold my cad, I bought me a Jeep, I got that bug and I can't sleep. Uranium fever has gone and got me down. Uranium fever.